Welcome to Straight Talk from the Dorothy Hodgkin Project, a new Oxford initiative to support women in science. This series offers insights and personal experiences from top scientists. Alison Woollard supervised Sophie Gilbert's DPhil in the development of the nematode worm, and Sophie acted as an assistant when Alison gave the Royal Institution Lectures for Children in 2013.
The problems of society are growing, aren't they? Lots of, when you think about the ageing population, you think about the emergence of antibiotic resistance, and you think about just being able to feed everybody. And a lot of those problems have scientific solutions. You can always say there's never been a more important time to go into science, but there never has been a more important time to go into science. So what was the best moment in your PhD, do you think?
The best moment was seeing something down the microscope in worms that have been studied for many, many years, and showing it on a slide during a talk, and people who've been in the field since it began, having never sseen it before, and saying, wow, we missed this.
Or they'd seen it, but they hadn't seen its importance, and that was the thing. It was just the right time for you, because you got to that time of your PhD when suddenly you were in the driving seat of your project. You'd learnt enough to know what constitutes an interesting question.
Yes.
And to see things, to see what's really interesting, and to pick out things that are really exciting. And I remember very clearly that lab meeting when you showed those pictures and you just said, well, this is it. This is the solution to this problem.
Yeah.
And all of us sort of going, oh my goodness. So it is. How ridiculous.
It's very simple and very, but it had been missed. And so it just shows you just have to pursue, and there's lots of things that you miss even when you're,
Because that wasn't really the primary...
No, it wasn't the primary question at all.
Yeah. And sometimes the primary question can turn out to be, in the end, a bit dull, or not the right way to look at it.
Not as interesting as it first seems when you go into it.
But it's by doing this observation, it's by spending so much time looking down the microscope so that you sort of really have this relationship with this organism, that you see things, and then suddenly you see them in a slightly different way.
And being very open-minded, I think, is very important.
Absolutely.
So you can't be too focused on one thing and one output. You have to...
Yeah, I think that's absolutely true. And also I think that in some ways it's better not to be so full of facts and reading that you feel almost sort of catatonic in the face of all this knowledge. That if you know absolutely everything that's going on, it sometimes obscures that creativity, that ability to say, well, maybe this is important, or this is what I've seen, and it's occurred to me that this is the important thing. I think that's a really striking thing about science.
So when was your best moment in your career?
I think when I was a PhD student, I struggled to knock out my gene, and it just wouldn't work. It wouldn't work. And I tried it for months and months and months, to the point where I used to feel physically sick when I went into the lab in the morning, because I was so wanting this experiment to work, and I would see very clearly if it worked or not. And I actually felt physically sick when I took the plates out of the incubator to see whether or not it had worked. And I remember the day that it had worked. And actually it turned out that the phenotype of this knockout wasn't that interesting, but that didn't matter. I had, been in adversity with this experiment, and I had to keep trying, and eventually one of the tweaks I made did make it work, and that was really important for me. And then I think when I switched to work on C. elegans, the first time I ever cloned a gene. So in C. elegans you have these mutants, and obviously you're interested in a particular mutant because it displays a defect that you think is really exciting. And of course the next thing to do is to find out what the gene is that's gone wrong to produce that defect. And that's quite a lot of work, right? It involves a lot of mapping and trying candidates out. And I remember the day when I found the gene for my first mutant that I was interested in. That was That was amazing as well, looking down the microscope and seeing, because you put the DNA back into the worms in a very sort of thorough way. So you try one and then the other and then the other, and you do it for months and months and months, and then you look for the one which makes the mutants normal again, so it sort of rescues them. And I remember coming in and looking down the microscope and seeing these rescued worms and thinking, oh, it's worked! I can't believe it. And of course it turned out to be a really interesting gene as well. So that was doubly good. I find that, to me, is the most important thing in many ways to communicate to the public, because I think there's a great thirst for knowledge and science in the general public. I'm always amazed by actually how much people know. I think what people are really fascinated with is how it's done, because I think you can tell people lots of facts in a very didactic way, and it seems like knowledge coming from on high. Should you believe it? Should you not? You know, we're in this era of fake news and all this thing, and people say, well, if it comes from a scientist, it must be right. But it's very hard for people to accept that unless they have gone on that journey of knowing how to turn research findings, how to turn an experiment into an evidence base. And I think people are absolutely fascinated when you go through with them, you know, okay, in a very minor way, we know that this gene controls this process in a worm. Well, how do you know that? Well, we start off with these worms that are broken because they've got a defect in one of their genes, and then we put the right DNA back in again. We fix the gene and it works again. So that's really good evidence that this gene controls this process. And I find when you talk people through the actual mechanism of what that involves, the looking and the putting the DNA in and so on, and how you do that, I think people are always fascinated. And I think then people can understand that if there is all this evidence that supports the fact that, for example, climate change is caused by human activity, then it becomes much easier for people to appreciate that that's right, and that, you know, that has to be acted on. So I think it's this engagement with research and how it's done that's really, really crucial.
I was in charge of, I had a prop that I was in charge of pushing on and off the stage, and it was a 1.5 kilo lobster bought from a Mayfair restaurant live, and I had to keep it alive for 3 days while filming was happening.
Because the lobster was a good example of an animal that lives for a very long time, wasn't it?
It was, and we used to say this lobster was pretty crucial for quite a lot of the.
Yes, I remember I had to hold it in one of the lectures. I was terrified it was going to.
It was huge.
It was huge, and had really scary pincers, didn't it? They were taped together.
Yeah, it was the biggest lobster I've ever seen, and it was very angry as well. And actually, at the end of filming, the film crew, I found them in a room and they were drawing straws as to who was going to get the lobster to eat it.
Oh yes, I remember that.
And I was so outraged. I thought, I've looked after this lobster for 3 days of filming, you're not eating it. And I rang up zoology in Oxfordville, a friend helped me, and they were very, very nice and said...
Because they have all these tanks, don't they, to keep animals in.
And they said, well, if it's quite a small lobster, they could probably take it. And I decided just not to mention how big it was because I didn't have an alternative as to where I was going to house this lobster. The lobster was rehoused and put on in an exhibition tank. And they actually christened it Arnold Schwarzenegger because it was the most aggressive lobster they'd ever encountered in zoology. I'm very lucky because I have a lot of supportive people helping me and helping my career, which is very important. I think people are very interested in your PhD students and postdocs, and I think that's very, very important. You need someone to believe in you.
But everyone has their special sort of thing that they bring, I think, to a research project, and the thing that you bring is this extraordinary observational ability. So you see things that other people haven't noticed, and that's exactly what we talked about when you said that, you know, you noticed that the importance, the significance of this particular thing that you saw down a microscope. But that's that talent that you have. That's a very creative talent. That's looking at something in a slightly different way and seeing it in a slightly different way, and then using that. That's the narrative of the science of the story there.
This is Straight Talk from the Dorothy Hodgkin Project. Please share this and make a gift today at www